James from Lucid Games to do a bit of a programming workshop with us, go through a bit of his time at Lucid Games and how he managed to get there, as well as showing us a little bit of programming development on the go, really. Going to be working with C++, correct? Perfect, awesome. So we'll have a QA section at the end, so you can kind of shout out questions, anything relating to James and his time. Yeah, enjoy it. Round of applause for James, everybody.
Thank you. So yeah, I'm just going to kind of go over a mix of stuff, really. It's going to be, I'll start off with just a bit about me and then kind of go into what my experience was like moving from university and then going on to actually work in the games industry, I suppose, and then just kind of, there'll be bits of all sorts in there along the way as well. It'll be a whole journey of all sorts. It'll be a surprise to all of us, I'm sure. So I graduated from Liverpool John Moores in 2020, so that's pretty much 2 years ago now. While I was doing my degree, I took a year out to do an internship at Lucid Games, so that was mid-2018 to mid-2019. And then since I graduated, I have been full-time basically ever since then. My first project was Need for Speed Hot Pursuit Remastered. We've done quite a lot of external contracting work with EA. We've got quite a good partnership with them over the last sort of 7 years now or so. So I started off with UI programming on that and have also done UI programming more recently on EA Sports PGA Tour as well. And then I've also worked on some other things, but I can't speak about those, so sorry. I see myself as quite a generalist programmer, really. I'm not necessarily specializing in UI specifically. I've kind of got a good knowledge of everything, and I'm currently moving on to work with other things other than UI, so I'm kind of a bit of everything rather than specializing in one bit. And got a lot of experience with Frostbite at this point, which obviously I can't speak about so much, but as well, I've got a lot of experience with Unreal Engine 4 since that's what I used at university, and for personal projects and stuff like that, because obviously I can't use Frostbite for anything else. So the first thing I think which kind of gets thrown around a lot is this focus on kind of like what you want to do. And I often think that there doesn't need to be so much of a push for it. That's one thing I learned was kind of like, I was always stressing when I was in university, kind of like, especially reaching towards the end, I was like, I don't even know like what I want to specialize in. Like, I always knew that I wanted to do programming, but there's so many areas. You know, you've got gameplay, UI, physics. You can do graphics programming, and there was sort of some people around me, and I'd known some people that would graduate, and they'd be like, "Oh, I really want to do graphics programming." And I'd be like, "How do you know that that's what you want to do?" Because I have no idea. Like, I haven't touched enough areas of code to know that I want to specifically go into this one area. And I kind of learned that you don't need to know so quickly. Like at 22, 23, whatever it is going to be that when you're graduating, it's kind of like, it's not important to really know, oh, I want to specialize in this thing. If you know what you want to do, that's great. You should go for that, and that's fine. But don't necessarily feel pressured to do things a certain way just because other people do it that way. Just do whatever you want to do. Go with it. You can change your mind down the road if you want. You'll be given opportunities if you work in the right place. So it won't be a problem down the line. So as a programmer, I can obviously only really speak to the programming side of things as opposed to any of the kind of art or production or anything like that. So some of the major skills which every game studio is looking for, really, the biggest one you'll always see on any kind of required experience or whatever, it will mention C++ because the majority of game engines use C++. And also math skills as well, which is kind of like, it is very important, and it kind of, the type of maths that you'll be doing, it depends on what you're working on, kind of thing. Like, if you're doing physics programming, obviously that's going to require a lot of physics skills, which also comes with its own maths. Graphics programming is going to be a lot of matrix work, stuff like that. So if you're not the best with maths, that's definitely something to brush up on. It's not something to stress about as kind of like oh, I don't know everything, like I can't do this. It's just kind of like needing to have the basic knowledge there. And you don't need to remember all the equations and stuff like that. There's this weird kind of like idea that I think school pushes into you where you need to remember all these equations or whatever. Like, you're sat at a computer all day, Google is right there. You can just Google what the equation is. Like, no one needs to remember that stuff, although you will get asked about some of it in interviews, so that's something to be aware of for those. But other than that, I don't remember, personally, I don't remember what the dot product is. I'll just Google what the dot product is, for example. Problem solving is kind of the most obvious programming skill, I think, which is most often attributed to it, because that's essentially what a lot of the job is. Like, anyone could learn to code. Like, you could teach a monkey how to code, probably, because it's just typing out letters on a keyboard, but it's kind of, it's easy when you're told a problem and how to solve it and what you're doing. Like, oh, you're learning about like how to do loops or whatever, like for loops. It's easy to be told, here's how you do a for loop, and then anyone can type that out and be like, oh, great, I know how to program, but you're never given a task to do and then told, here's how you do it. You have to figure that out yourself. You're just told, like, oh, go implement all these weapons and like let the character pick them up and go and shoot them at some enemies. And it's like, how do you take that and put that to the point where it's kind of like actually functioning in a game? Like, there's no guidebook necessarily on what techniques to use to get there. Object-oriented programming is how, I guess, every game I've ever known has been made. There's some sort of like moves towards data-oriented stuff, which is quite interesting if you want to read up on that as well. But object-oriented programming is sort of the biggest thing that you should learn, I suppose, if you're wanting to make games. There's sort of some bonus skills as well along the way, which you might pick up on. These will often be kind of in the additional bonus experience or whatever if you're looking at kind of job applications. So stuff like Lua and Python will be used for kind of like scripting, which can be more of can be programming, can be kind of technical designer area. So if you see yourself in more of kind of a designer role, but wanting to do a little bit of programming here and there, technical design could be the area if you really want to specialize in scripting, and then kind of like, it will be a lot of more gameplay-focused scripting side of things. C# is often used mostly for tools development and stuff like that, so kind of like for enhancing development processes themselves. That will mostly be going over C# rather than C++, sorry. So building a portfolio is essentially your main goal throughout university, really. That's kind of like, by the time you reach the end of university, the portfolio is the thing that you need to have there ready to go and put out to people to get your jobs. So you don't just want to include your university assignments, because this is always told to people and some people still won't listen, but I'll say it anyway. Because if you get 10 people all from the same university, all given the same assignment, all with the same assets, and they all submit this portfolio, which all has the same project, which looks very similar to everyone else's. It either looks like everyone's just copied the same project, or there's nothing which makes you stand out, essentially. You really just need something which is your own to kind of say, it's like, it has a lot of your own personality in there as well, I think, and that will come across in interviews, I think, especially when you've got something which you're really passionate about and you've put all your time into and it's your idea. And when you speak about that in an interview, that will show through way more than, oh yeah, we got told to do this assignment and I kind of had to do it for the deadline and like, it was their idea or whatever. Like you may not even notice it, but you'll speak about it in a lot more of an interesting way when it's something that you're interested in than something that was given to you. You want to have a mix of solo and group projects in there too. Group projects are important because obviously you're not going to be doing much solo work when you're in a dev team of however many people at a big company or even a small company. So you need to kind of show your ability to work with a group, and don't just complain about everyone else in your group, because that's another really common thing. is there's like, oh, how did that group project go? And they just go, oh yeah, everyone else on my team was awful. I had to do all the work and all this. And it's like, that's just not really the way to talk about it. You've got to speak about it as if they're in the same room or they're going to hear what you're speaking about. And also quality over quantity is another big one. Don't have 10 projects from your first C++ project with like a hello world thing or something stupid like that, because they're just going to think you're taking the piss, essentially. Just show the really good stuff, two or three projects even of just really high quality good stuff, showcasing different skills of your best work. That's what you want to see, because that's all they're going to look at as well. They're only ever going to look at 2 or 3 things max. Like, they're not going to have time to go over every single project that you've ever done. You really just want to pick the best stuff and kind of go from there, really. From there, it's pretty much just all about making things as easy as possible for them. People tend to overcomplicate some of this stuff, and it's just because everyone else does it in the same way, you don't have to be the smartest person by doing something different. Like, just having a LinkedIn page with all easily accessible links on there is a good way to do it. You get loads of recruiter messages, which become really annoying after a while, but I'm sure they'd be very helpful when you're actually needing a job. Keep a website nice and simple. Don't make your own website, because we're not web developers. We're not trying to prove that we can make websites here. We're trying to show that we can make games. And if you make your own website, you're essentially showcasing skills which are a bit of a waste of time, making things harder for them because it might not look as easy and accessible as it could, whereas you can just use something like Wix or Squarespace or whatever they are, just to use their templates and just stick all your stuff on there and just literally link to CV in the biggest font you can imagine or whatever, just so they can easily download it and easily look at it. A link to some videos, YouTube, whatever, GitHub maybe if you want to show some code, that's how you put stuff up. Playable demos are another thing. You could have a link to, like, I think Google Drive's probably the easiest way to do that. Just link to a Google Drive doc and just kind of have some demos that they can play around with. And taking playable demos to an interview is another really smart way to kind of make an interview easier for you. Mostly because it kind of just gets them hands-on and they're doing something and they're kind of busy with that, and they'll ask you questions as they're going along with it, and they're not sat there staring you in the face where it looks like they're going to eat your soul. It's kind of like a lot more relaxed because they're just playing a game at that point then, and then you get to talk about your project, and it just feels a lot more natural. You want to try and make an interview as natural as possible. You want to try and make it just a conversation. It doesn't have to be such a formal back and forth, question, answer, like robots, because I don't think, looking at it from the other side now, if I was going to be going to interview someone, I don't want someone like that. Like, I remember when I first joined as an intern, actually, and we kind of spoke about what my interview was like. And the guy that interviewed me, or one of the people that interviewed me, actually said that when they're interviewing you, they're not necessarily looking for you to be the best programmer in the world, because they can teach you a lot of the programming stuff. Like, if there's any gaps in your knowledge, they can teach you programming on the job sort of thing. The way he worded it was, he's specifically looking for someone that he can sit next to and not want to punch in the face, which is honestly a good way to put it, because that is the most important thing, is being able to get on with people, because you're going to be spending so much of your life, 40 hours a week or whatever, with these people. Like, you want to be able to get on with them and kind of make work as enjoyable as possible, sort of thing. Make sure with group projects that you're very clear with what work you actually contributed and stuff like that, because you don't want to be stepping on other people's toes and taking credit for things which weren't yours. And then I often found with interviews that I had that it's kind of, they'll ask, with group projects specifically, they'll ask more about the experience of working in a group, the kind of process of itself, like, how did you plan things? Did you use something like Trello to kind of like organize and manage the project? Was there kind of like someone who was more of a leader, or was it just kind of everyone divided into their little sections? They'll be the sort of questions that you want to ask. And I think one thing I wish I had done as well was every project which I worked on, I wish I had made notes on the project sort of after I'd finished it, because I'd go back to look at something 2 years after I'd made it or whatever, and I'd kind of have to refresh my memory on what I'd even made and how I'd made it and stuff, whereas a common thing to do in kind of the professional games industry is to do sort of like a postmortem at the end of it together, or smaller subsets of a team, and basically just kind of go what was not so good, what needs to be improved, and that's not just kind of the project itself of technical aspects, but also just processes and stuff like that. Oh, it took us ages to get set up with the project because we had to download all these different programs and set up all these files, and is there a way to streamline that to make it easier for the future, stuff like that. So I think it's almost quite a smart idea at the end of your own projects to do something similar. Just make a few notes, like here's how did I make this feature? Like, oh, I used this like open source software to kind of as a plugin with this to make this, and it's kind of just easy then to go back and read it and go, oh yeah, I remember like making that thing or whatever. Because some people might have a really good memory, but I definitely don't. So making as many notes as possible and things like that is, for me, something which I wish I had done a lot more, because it took a lot longer, I think, to kind of prepare for interviews when I had to refresh my memory, so to speak. With any kind of university or school opportunity, while you're here, you really just need to make the most of it, which I tried to do, but I know a lot of people kind of don't. You know, you're paying them whatever amount of money in a lot of cases to kind of be here, and you're paying for all of this stuff, and it's just not direct. You're just kind of like, you just see it as the loan or whatever, but you want to kind of like, yeah, just make the most of what's given to you, really. So you kind of got like, they'll often have like a lot of software licenses and stuff. I mean, Unreal Engine, for example, which I think is a good place to start, not start, but a good area to focus on when it comes to like wanting to program games, because it's so widely used that a lot of places will look for Unreal Engine experience, and it gets you used to C++, and it's a modern AAA engine which is used to ship some of the biggest games in the world, and it's open source. You can download all the code for the engine on GitHub and have access to it all, and that's without any university requirements, but universities will also have their own things which can be useful. Books from libraries and stuff like that. I've put a couple up there. Effective Modern C++ by Scott Myers. I think Myers, don't know how you say his name, but I'm not really a big person with books. Like, I struggle to kind of sit down and read a book on something. But that was very interesting and provided a really cool insight into a lot of things and a lot of kind of like modern C++ techniques and tips and kind of things like that. And if books are something that you're really interested in, then that's definitely something which you should kind of go down. But you can also take like Udemy courses and stuff like that if there's a certain specific area which maybe isn't covered in a course, but you kind of want to look into. I could probably recommend some good ones of those if you wanted to email me or something, and I could kind of go with that. Talk to lecturers and anyone really that you can get in contact with, networking, stuff like that, because there'll always be fun stories that you'll hear about. Kind of like, it's all well and good me standing here and talking about my experience, but because it's so planned, it's kind of like not, a lot of this is just kind of ad-libbed, but it's just, you'll just hear some really fun stories just that will just randomly come out whenever you speak to people, so it's kind of worth just kind of talking to people, really. Get your CV checked as well. There'll often be kind of like careers advice people at universities. Make the most of them as well, because they'll kind of know what to look for. Just proofreading tips for kind of like how to lay it out, stuff like that. Because again, it's just making it as easy to read as possible. But also get that checked by lecturers or someone else, whoever's willing to give you the time of day with that stuff, because they can provide more of an insight into the game-specific side of things, kind of rather than just the professional side of things. Practice interviews are another thing that I did. That was something I did before going for my intern interview that I had at Lucid while I was still at university, because I had never interviewed for any job before, not even kind of like a part-time job. So that was kind of like a new experience for me, and I just kind of wanted to be a bit more relaxed about it. And just having a practice interview is just kind of like, it gives you a chance to completely mess it up and not have any kind of like repercussions from it, essentially. It just gets you a bit more relaxed, and then when you go into the real thing, it's kind of a bit more familiar. Set up a game jam maybe as well, if that's something you're interested in. Kind of like people on your course might be interested. Divide up into like little teams or do it on your own, whatever, just kind of over a few days, a weekend, whatever it might be. And just kind of like make a game over a few days. Don't kind of like, I'm not necessarily a big fan of the whole like 48-hour game jam, don't sleep type thing, because that is encouraging the type of workplace which we're trying to avoid. So maybe do it over a week and just kind of say like, oh, do 5 hours a day for a week and just see where you end up, sort of thing. They're always quite fun to do and stuff, and it's, I mean, I know when we were at university, we kind of had stuff similar to that, and then we could usually get the university to like provide us with pizza and stuff like that. So if you're nice to people, they might kind of let you do something like that. I just said that just to drop them in it, because now they have to do it because I've said it. So I've kind of dropped some general interview questions. Some of these are going to be asked every single time you go for an interview, and I can almost 100% guarantee, and sometimes I don't even know why, but they just love to ask the same questions, it seems. So they'll obviously kind of have your CV right there. They'll have your portfolio right there, maybe open on like a big screen or whatever, or if it's over Zoom, because a lot of interviews probably are like that now, that'll obviously be kind of handled in that way. They'll pretty much just be going over whatever projects you've got and say, how did you implement this feature, like at a technical level? This is obviously specifically for programming. Anything else will be slightly different. I have no idea what that would be like. And also how you would improve it as well. That's going to be one of the big things that they'll want to get from you, because I often found that was quite an interesting conversation to have, because I would have a project from maybe 2 years ago. And when I was kind of graduating, in 2 years, you've changed a lot, and you look back on everything and kind of go like, that is awful now. And I think if you don't look back on code from a year ago and say, that sucks, then you've not really progressed anywhere. That's actually a good sign. Like, I remember every time I would look back at an old project and I would think, I'd find glaring issues with it, or things I would have just done completely different, or anything. And I'd kind of think like, I really suck at this. Like, what am I doing with my life? But realistically, it's just showing that you have got better over the last year, or you've developed new skills which kind of like have improved you to the point where you can look back and say, oh, that's not so good. So being able to talk about those things and saying kind of like, I remember I put in some really bad AI for one of my projects at a point where I'd not learned anything about AI programming or pathfinding algorithms or anything like that, and I'd just kind of gone, oh, I kind of want some enemies. I don't know how to do it. I'll just sort of make them be able to walk through walls and go directly to the player, because I didn't know what else to do, really. And it kind of came up in like an interview that I had of, you know, what's going on there, basically. So that then just gave me the opportunity to say, oh yeah, you know, made that however long ago. Here's how I would do it differently. Here's how I would improve it. What else have we got here? There'll be technical questions as well. I think the amount of technical questions which get asked kind of vary depending on the company. I've had some interviews where they've asked literally, it's been quite strange because they've kind of started off with a bit more just kind of like casual conversation about projects, what you've done, how you've done it, which will be quite technical because they'll be looking for you to go into details on like what techniques you use to make anything. But then they'll just kind of go, okay, I've got like a few technical questions here, and they'll just fire like 2 or 3 technical questions at you and just kind of expect just answers back from them, and that would just be kind of their, just getting the idea that, I think it's pretty much just a sanity check to make sure you're not an idiot, I do think that's all it is at this point. I don't think they're really kind of grilling you to make sure you know everything. So if you make a small mistake, it's definitely not the end of the world. They'll be able to tell whether you know what you talk about, what you're talking about, and if you don't, which is another really good tip, because one of the stupidest things you can do in an interview is them ask you a question and you to act like you know what you're talking about when you have no idea, because they will absolutely pick up on it, and they will have so much fun with watching you sweat as you dig this hole for yourself of trying to act like you know what they talk about. And they'll be sitting there having the time of their life laughing at you in their head, whereas you should have just gone, I don't really know, but I can give it a go or whatever, and then kind of they'll appreciate the honesty. They're not looking for you to know everything. I had 2 interviews for my current job at Lucid. One was when I was an intern, and one was when I was a graduate. And both times there was a couple of questions at least which I couldn't answer, and I might try to answer them, or I would just literally go, yeah, I don't know. And they'd often just be kind of like, oh yeah, that's fine. Like, I'm just looking to kind of get an idea for where your knowledge is at, where the gaps in your knowledge are, because everyone's going to have gaps in their knowledge at any point. So that's all they're kind of looking to find, really. But yeah, some examples of technical questions there, kind of, you may know what a lot of these are, you may not, depending on your kind of like level of experience with programming and stuff like that, but smart pointers seem to be something which I noticed coming up in interviews quite a lot. I have got a little kind of slide on those a bit later on with a more technical explanation for them if you don't know, but you can sort of feel very impressed with yourself if you already know what they are, I suppose. Dot product and cross product, that is the one which will 100% come up in, I think, every interview ever. And I don't know why. I think it's sort of just become this thing where everyone's accepted that it's just a question which gets asked. So not only is it just remembering what the dot product and cross product are, but it's sort of like a good example of how you would actually use them, like where you would use them in a game sense. Like, I've had some good disguised questions with it as well, where they'll kind of ask a question on like, oh, okay, so the question I got asked, which is probably my favorite interview question which I got asked, and I wish I'd come up with it because it's quite a good way of asking this question, is you've got an object in random 3D space and a camera also in that 3D space, both at random locations. You don't necessarily know where they are. Well, no, you do know their position, but how do you find if the object is in front of or behind the camera? And that's all they'll give you. And I think if you don't know, that's very much a question of, I have absolutely no idea. But the answer is that you use the dot product and, should I explain it? Yeah, I suppose so. So basically, you can use the dot product between the 2 position vectors of both the camera and the object. And that will basically is giving you the angle between them. So if the angle is greater than 180 degrees, essentially, which will basically give you a value of, so I think if the value of the dot product is -1 or between 0 and -1, then the object is behind the camera. And if the object is between 0 and 1, then the object is in front of the camera, essentially. But you'll want to read up on that because it's a very bad explanation. I haven't gone over it very well whatsoever, but that's a good example of where the dot product is kind of wanted to be used. And that's a very interesting question. It's kind of a disguised question rather than just going, oh yeah, the dot product, what's that? Where would I use it? It's kind of like it's a better question because you have to know what it is without being told what it is that you need to know. I think that makes sense. Inheritance is another one which we'll get asked about quite a lot. I'm not going to explain that because that's kind of, well, it's a fundamental concept, I suppose, of object-oriented programming, so you kind of will want to read up on that and understand how it works and the different types of inheritance as well. Yeah. So in terms of the actual kind of graduation experience, so as I said earlier, I graduated in 2020, so that's 2 years ago, which also happens to coincide with when the world was set on fire. So that was fun. Yeah, we went into the first lockdown the end of March or something like that, and that was right when I was kind of finishing up writing my dissertation. So I had kind of like a month or 2 where I was just kind of getting on with that, and I wasn't really going out much anyway, so nothing really changed. But the thing that was the real struggle was getting interviews at that point, because everyone was kind of thrown up in the air. Like, all these game studios suddenly had to be able to work from home, which was not something which was really facilitated whatsoever in a lot of places. So a lot of places just kind of had to go, we are not in a position to be able to hire people because we can barely set up our own current employees to work. So that was a problem. And it led to kind of like a big demoralizing of things, essentially, because obviously it's just so hard. You've worked for 3-4 years, and then you reach this point where it just kind of feels like you hit a wall. And I think everyone will face some kind of obstacle like that. Hopefully it's not some global pandemic which is killing your grandma or whatever, but like there'll always be something which is like gonna get in your way, and it's gonna really be a struggle to kind of like find that extra bit of motivation to kind of like push through it and like just keep going. Because I really do think like if you're good enough at something and you just put all of your effort into it, like you will eventually get there. It just requires that kind of level of commitment and admittedly a lot of luck as well. Also just kind of thinking about priorities is kind of an interesting thing. There's a lot of you kind of get into games mostly out of passion, because you're definitely not in it for money, because you could make a lot more money doing a lot easier work, doing almost any other type of programming. So you're definitely doing it because you love to make games, and that's what you want to do. And I think I noticed when I actually started working that it was so much more about the people that I'm working with, because the great thing about working in games is that every single person that you ever work with all has at least one common interest with you, and that is games. Like, you can start a conversation with any single person that you're working with immediately, because you can just talk about video games as a fallback if there's nothing else. And finding the right people to work with in that sense is, I think, the most underrated and most important thing, because it just creates this much healthier culture of kind of like everyone supporting each other and being behind each other and wanting everyone to be their best self and stuff like that. And that just kind of leads to better games being made and stuff like that, as well as just a kind of better experience for everyone. Another thing with interviews, which I forgot to mention earlier actually, so I'm glad I put that up there. It's not just about you being interviewed, you're also interviewing them for their place of work. You can kind of like try and get an idea for what sort of projects they're working on. Like at Lucid, we're never just working on one single project. We don't kind of have all our eggs in one basket in that sense. Like there's always multiple projects going on. I don't even know how many projects we've got going on at the moment, and I probably can't say, but it's more than 2. So you can kind of get an idea for like what sort of things they've done already, like what you can maybe get sort of hints of what they're doing at the moment. And as you kind of gain more experience, you can find out more, essentially. They'll maybe get you to sign an NDA before the interview, and kind of like you can ask questions like, oh, what project? Because I've known people to be hired specifically for a project. They've really wanted to work on this specific thing, so they've been hired for that project. And if it wasn't for that project, they probably wouldn't have come. So it becomes so much about you asking them questions, what it's like to work there. You can ask anything that's important to you. That's your opportunity to find out, is this the right place for me? For, maybe you want to know what kind of like benefits they've got, or like how your salary could like increase over the years, stuff like that. And that's your opportunity to ask about it. Like, it's not just kind of them grilling you and getting to know you. You want to get to know them as well as people and the company as a whole, sort of thing. So moving on, it's kind of just going to be going over the general sort of like idea of what my work is like, kind of like from since I've graduated, what like a typical day looks like, the type of things how a project works, some things which maybe surprised me, which I didn't know about as a student compared to kind of like moving on. The obvious one is there's not really like a dress code. You don't have to show up in a suit or anything like that, as you can probably tell. It's not professional in that sense, which I personally quite like. Flexible working hours is quite a big thing, which I wasn't really aware of as being a big thing in the games industry, but I think a lot of companies do have some form of flexible working hours to kind of allow for, well, just suit everybody's needs. Because, for example, at Lucid, we have kind of a set of core hours, which are 10 a.m. to 4 p.m., and then you have like an hour lunch break in there, and then you also just work 2.5 hours around those core hours, whichever suits you. Like, I know people that love to wake up at 6 a.m., go to the gym, come back and start work at 7:30 and then finish at 4. That works great for them. I can't imagine anything worse, personally. I wake up at 9:30 and start work at 10 and then don't finish until 6:30. Because I get all my work done in the afternoon, and the morning is me trying to wake up, basically. So it just leads to a lot of, like, it provides the best opportunity for everyone, because there's no forced kind of set, you have to work this way. It just opens it up a bit for everyone. Open plan offices are another big one. As far as I'm aware, I mean, at any studio I've ever seen, at least, they're very open plan with this stuff. Just kind of like rows of desks with people. There's no kind of like, oh, the big boss man is in like his office sort of thing. It's like he's just on a desk opposite you or whatever. It's kind of very open, encourages kind of like socializing as well, which is quite nice. There's a lot of talk about kind of like flat company structures and stuff like that as well. The way I have always sort of like looked at that now is you obviously have levels of kind of management and seniority and stuff like that, the founders of the company and the kind of main leads of a project, technical leads, stuff like that. But I think the idea of the kind of like flat structure comes from you can only know what you know, and that applies to project-specific things. We're kind of like, the industry is always moving and progressing and changing every single year. So even as an intern or a graduate or whatever, there's going to be things which you know which someone 20 years senior than you is not going to know. Like, if you're told to implement this system like a grenade system or something, you're going to be the only one who knows how the grenade system works in the game. Someone who's more senior than you, just because they've got loads of experience, doesn't mean they can come along and go, oh yeah, this grenade system, it works like this, and here's how I change this. Like, if they then come along a few months later and need to work on that, they're going to come and ask you questions about your grenade system. Like, it's not so much of a kind of you're always talking to the senior people and asking them questions and asking them how everything works, because you just need to know the right person to ask for whoever's implemented it, and that might be the intern or the technical lead or whatever. Like, there's no kind of like go-to person for every question that you might ever have, which is kind of a lesson which I guess I learned kind of only when I started actually working in the industry. But now it seems obvious looking back, so maybe I was just a bit stupid. In terms of project structure, you might be kind of familiar with this or have at least seen a lot of these terms before. And I think this just kind of like outlines the stages of a project through the whole process. And depending on where you're at in these kind of like stages, it will really vary the work that you're doing. So for example, prototyping and pre-production, that's going to be a lot more focused on kind of like documentation and like design, planning, stuff like that. Production is going to be when you're implementing a lot of features, doing a lot of coding, actually creating stuff. And then the kind of like alpha and beta stages are going to be when you're doing a lot more bug fixing and polishing, stuff like that. Gold Master is the final kind of code game release. And then post-launch stuff will be DLC or just post-launch bug fixes, because nowadays, back way before I was ever making games, a Gold Master would be the first disc which you printed on, and that was the code which went out, and that was it. bugs on there were the bugs which shipped with the game. That was it. There was no patches, day one patch, and like whatever. It was just kind of, this is what you get. And luckily, that's not how it is, because games can't, I don't know that any game would ever be able to, I think everyone would hate every single game ever if that's how they were made now. Because everyone would not be able to complete a game or get a trophy or whatever. So in terms of production itself, you kind of follow this agile process, which will be talked about a lot. It's not exclusive to games development, but it's definitely always used in game development, because it essentially, rather than following the kind of stages of like design, creation, testing, release, or whatever, there's kind of this agile flow of constant iterations on things, and that's obviously a very common thing with games, because designs are always changing, and designers love to change things on you after you've spent weeks implementing something, and then you have to redo the whole thing, which isn't annoying whatsoever, obviously. So the kind of process of production will essentially lead to everything will be designed, planned out. Game design documents will be made. Technical design documents will be made based on the game design. And then based on all of that documentation which has been created, you'll have a bunch of tasks which are created for all of the features in the game to say, what do we need to actually have all these features up and running? Then the leads, the lead programmers, lead production on the project will basically delegate functions out. They'll obviously be the kind of like, there'll be broken down subsets of teams. There'll be kind of like the gameplay team, the AI team, whatever else, however it's broken down. And then the leads of those teams will kind of delegate functions to certain people based on their skill set and various other things. And then across production, you'll essentially have like a roadmap plan with a series of milestones. You'll kind of start off with pre-production. The date will be whatever. There'll be kind of a date however long down the line, which will be when you want to start production. Then you have the date when you want to hit alpha, so when you want all the features implemented, basically be able to go from start to finish in the game, essentially. And then a beta date and a gold master date and a release date, which all of that will be fluid and stuff, but it just gives you a rough idea on kind of when you need to be at each stage and what milestones you need to hit to be able to know you're going to be able to reach those stages, essentially. And then to get through those milestones, you'll basically have those broken down into sprints, which will usually be, in my experience, have always been 2 or 3 weeks long, which is basically just a set amount of time where you're given a task or 2 tasks, 3 tasks, whatever, and that's what you have to get done within that sprint. And if, theoretically, the idea is that if everyone gets all of their tasks done in that sprint and all the ones in the next sprint and every single sprint, by the end of it, you'll have a finished game. That's how it works in an ideal world. So tasks will get assigned out at the start of the sprint. This is all very boring stuff, unfortunately, but this is what we have to deal with. Then you kind of have your daily meetings with the team to kind of like go over where your progress is at. If you're kind of blocked by anything, if there's something you're waiting on someone else to do something, that's your chance to kind of speak up and do that side of things, which again kind of leads to the level of communication that you need. People think of programming as a very solitary, you sit there and code all day and like ignore the rest of the world or whatever, but it does require a lot of communication between all different departments. You need to kind of like be able to talk to anyone about all sorts of problems, really, and that's kind of where that comes into things. Then as things are being implemented, obviously you have the QA side of things. They'll basically just be running over all the features, testing them extensively, and coming up with any bugs, creating them, which will then come back to you. If you implemented a feature and a bug is found within that feature, that will usually come back to you as something to fix at some point. So Jira is sort of what manages the whole project. It's basically like where you create all the tasks, where they're all assigned, where you go to track your progress with how you're getting on with things, what other people are working on, and it can basically be summarized with these 2 pictures. No one likes Jira except for producers, and producers are crazy. So a typical sort of day in terms of kind of just the general flow of things. Again, this does vary a lot. It depends on where you're at in production and things like that. But for me, I always start the day with just getting latest. So Perforce is the kind of source control software which we use. You may have used Perforce before, or at least heard of it, or used something else, kind of like GitHub, whatever. It's a really cool tool, and it's something I definitely recommend kind of using if you can for university projects, especially group projects, stuff like that. It gives you like a tracked version history of all the files. So if I create like a character class and just do some basic stuff with it, he can run around or whatever, and then someone else comes in and adds like jump features, and then they submit that to the server. It will basically have a tracked version history with like who submitted what on what date, and a little description of what it was that they added. And it's just really useful for just like, once you really kind of like master using Perforce, it makes debugging a lot easier as well, because you can sort of see where an issue came up. And there'll be kind of easy ways to kind of like, it's called like diffing files. So you basically just see what the difference is between this file and this file, basically what was changed, what was added. And it just makes it a lot easier, because it's like, oh, there's kind of like, if you know a problem was kind of introduced at a certain date, you can kind of like look at that file and see what was changed between those dates, sort of thing. So it's something I definitely recommend looking into and kind of like getting a good grasp on. So yeah, you basically just want to get latest at the start of the day. That would basically just be downloading from the server where the main project is stored all of the latest stuff which has been implemented in the last day, I suppose, by everyone else. And then you just kind of want to like build the code and cook any of the data that's needed to run the game. And that will basically just kind of test for just, is it actually working? Like, has anything been broken in the last day, sort of thing. While that's all going on in the background, that will take like an hour or so of your first day. That's when you can sort of check on your messages, emails, whatever. Slack seems to be the most widely used messaging app for everyone. It's pretty cool. It's useful for kind of like social and professional things all in one place, I suppose. Programming, obviously, is a big part of a programmer's life, fortunately. There is still some of that in there. That'll be, again, it could be bug fixing, it could be implementing a new feature, whatever that might be, just depends on where you're at. Meetings, which are mostly done through Zoom currently, still a lot of places working from home, stuff like that. They'll basically just be your daily stand-ups for sprints, and then also team meetings, stuff like that. Updating your Jira tasks. There's kind of different ways which different projects, different teams, different companies like to track things. It could be kind of like tracking hours specifically on how much time you put into a task and how much time it should have taken, stuff like that. So what is the actual process like for implementing a feature? You get given a task to make something. What does that actually involve? So again, the communication comes into it, because there'll be a designer who's planned out how this feature should work, what damage the weapon should deal, should that change based on anything else, whatever else it could be, anything. There'll definitely be questions which you'll have to ask them. So they'll often, it'll be clear who created the game design document or whatever, so you'll want to be able to kind of go and speak to them personally, and kind of, you don't want to, there's no point guessing. You need to just be able to open a conversation with them and just ask questions. In the pre-production stage, it could be writing technical design documents. So based on game design documents, you'll basically implement the technical side of things. So what technical requirements are needed to create this? How would it fit in with the rest of the project structure? All stuff like that. Hopefully, across kind of your course of things, you'll learn about game design documents and technical design documents, but if you don't or you haven't and you want to know, it's probably something which should be asked about, I suppose. Coding stuff is obviously then the next big thing, so that'll be when you're in production. That's when you'll be kind of actually given the task to implement whatever feature, and using the technical design document and the game design document and talking to any other programmers and designers that are needed to kind of like help collaborate with whatever that feature might be, or any dependencies on other things, because obviously some features won't be able to be implemented until another feature is implemented. There's no point trying to create weapons and stuff if there's no character there that's able to use the weapons yet. So you've got to be, there's just the obvious stuff, really. Testing things is one of the biggest things which apparently people forget to do sometimes. When you make something, you know, QA isn't there to make sure that you haven't completely broken everything. They're kind of there to just really dig in and find the bugs which you wouldn't find in your basic testing. So once you implement something, it's your job before you submit anything to make sure it builds on not just PC, but maybe a console as well. Does it build on PS5 as well as on PC, or is there a PS5 specific build issue? So testing it in that way and then actually running it and making sure there's not any massive crashes or anything like that which come up when you're running through the feature. That sounds really obvious, but again, you would be surprised the amount of times where I've come across things where I'm like, you didn't even test going onto this screen that you created because I did that and it crashed. But code reviews are something as well, which are kind of was a new experience for me, obviously. Moving from kind of solo projects where you just do everything yourself and you're just kind of used to making things and getting on with it. There can be a more formalized approach to code reviews or a less formalized approach. Sometimes it will be like, you need to get this reviewed by one of these people and someone else, and they'll have to check over it and approve it before you can actually submit it. Or it can just be asking the person next to you to look over your stuff. So I think that's kind of a good thing to get used to, is just kind of like get used to showing someone else your code and seeing what they think of it, like can they even make sense of it? Because other people are going to come across that in the future and need to understand it. So if they don't understand it, that's where you maybe need to add in like comments or something like that, or just make it clearer, just refactor it just to make it a bit more readable. So just while you're doing university assignments and stuff like that, just kind of hand your projects over, like swap projects with someone else, and don't worry, they're not going to steal it or whatever, but like just look over each other's code and kind of like get used to reviewing other people's code and having yours reviewed as well, I suppose. Then you can obviously, once it's been approved or whatever, you'll submit the work to Perforce. That's where other people can get it, and it will be kind of in the server for everyone to access. So just some interesting challenges is kind of like what I'm going to go over. Some things which maybe I wouldn't have expected or seen as a graduate, but found when I actually started working. So time zones is one of them. Like I said, like we've done quite a bit of work with EA, and I've worked on EA projects, and there's been different studios which we've worked with, some of them in kind of like more Europe, where it's not so bad, it's just kind of like an hour or two ahead, so you can sort of just get on with that fine. But then you have like the US-based like studios. And so like currently with the EA Sports stuff on PGA Tour, that studio is Tiburon, which is in Orlando. So that's 5 hours behind. So me starting my day at 10 even, which is the latest we can start there, at 5 a.m., they're not even going to be awake yet. So you kind of have to get used to the kind of offsets of when you can plan meetings with people, when you can organize talking to anyone, when you can expect replies to things, when you can expect code to actually be able to get reviewed. Because there's going to be that 5 hour time difference. They're not going to be starting work until your afternoon kind of thing, like 2 p.m. our time is when they may be starting work. So you kind of have to get used to that and adapt to things in that way. And then you're obviously going to have the opposite, where you kind of don't want to fall into the trap of it being the end of your day, but someone's still talking to you or wants to organize a meeting quite late and it's like 7 p.m. our time, but because it's their afternoon, they're trying to organize something and you kind of need to try and push back on that stuff because otherwise you'll end up working until 9, 10 o'clock or something, and no one should be doing that. So that then leads into kind of other issues where you'll obviously go on to your messages the next day and see an onslaught of messages from someone from the kind of like other time zone of asking a bunch of things, which is, well, yeah, somewhat stressful. Things always break. They definitely do. You will most certainly, the first time when there'll often be kind of like, from my experience, there'll always be some sort of like automated build system. So when I submit some work to the server, there'll basically be a machine which, when something's been uploaded to the server, it will basically, okay, I'll build the project and make sure it's not completely broken. And there'll be a time where you'll get that email which will say, you've broken the project, and you'll be terrified and you'll feel like you're going to be murdered or something. But everyone always does it, and it's just kind of like one of those things you have to go through. But then you'll also go through the thing where someone else has broken something, and it may not directly break the code so that it doesn't build, but you'll go onto a screen, and if you're doing UI work, for example, someone may have edited a certain widget, and that widget is used across multiple screens, and in your screen it's completely broken, and now your screen doesn't work, for example. So you've kind of just got to get used to coming across those problems, handling them, dealing with them as they come, because that's always going to be a thing. Again, another big push on communication is just trying to explain yourself and describe problems that you've got, or asking if this is the right way to implement something and actually being able to explain it. Because for me personally, I mean, as you can maybe tell from me doing this, I'm not always the best at actually articulating what's in my brain. I can feel everything is in there and I know the point that I want to get across, but it doesn't always come out. I can't ever be satisfied with the way that the words are coming out, that I feel like I'm actually getting my point across well enough. So it's kind of a good practice just to get used to doing anything like this, I suppose, or just, again, like rubber duck debugging type thing, just speaking to someone about a problem that you've got. And I found just speaking problems out loud to someone just kind of made me be able to explain the problems better, because I just got so used to describing a problem that I'd be able to describe it better every time, because I've just got so used to kind of like streamlining that. Another problem I certainly found, again, a lot of these problems are just kind of going to be specific to whatever circumstances, but I always found I worked quite late often with university stuff. I work best kind of later at night. Evenings into the night sort of thing was when I did a lot of my work, and because I got so used to that, it was hard to adjust to kind of like a standard working day schedule, and that could often lead to me overworking as well, because I'd kind of like not feel like I'd got much done during the day, and then it would reach the evening and I'd kind of then be reaching my productive hours where my brain's kind of firing on all cylinders, and I'm kind of like, oh yeah, I'll just carry on and keep working on this stuff. And through no fault of anyone else's, because they weren't telling me to do it, I just kind of like wanted to do more, and it just kind of led to overworking and stuff like that. And obviously I wasn't getting paid for it, so it was stupid, and no one should do that. So just get used to kind of working within your hours and not going too far beyond that. Working with older tools is always a fun one. So my first project was obviously a remastered project for Need for Speed, which was 2010, I think, was when it was originally released. So working with that in 2020, 2021, that's obviously kind of 10 years on, tools from 2008 maybe. You can often like upgrade projects to work in more modern versions of Visual Studio and stuff like that, but you may not be able to, you can't work in a new engine. You can't just kind of go like, oh, we'll just like move to a newer version of the engine or whatever it might be. It's kind of like you're often fixed with kind of certain processes. There might be like a whole production pipeline of how they created this game, and you can't change any one component of that pipeline because then everything breaks. So you just kind of have to adapt to working with these older tools, and it can be really frustrating at times because there's a lot of things which we'll take for granted that you just can't do because you're being forced to kind of work with these older tools, essentially. So kind of to go over some more technical things, I suppose. As I said earlier with smart pointers, they're kind of like a very common interview thing, and it's more of a modern C++ feature rather than kind of like more of a legacy thing which has been there. If you get a bit lost with this because I'm explaining it really badly, or you have no idea what I'm talking about or whatever, don't worry about it. It's just going to kind of like, you might know what I'm talking about, you might not, it's fine. Feel free to read up on it and find someone who can explain it way better than me, but just to give you a quick overview on that. So the problem with raw C++ pointers, where you kind of have the just like define with the little asterisks and then new, is the common rule with that is you always have to call delete whenever you call new. So whenever you're assigning new memory on the heap, with the new keyword, you always have to call delete to clean up that memory because it won't be cleaned up automatically. So when that object goes out of scope, that pointer will still continue to exist because it has there's no automatic cleanup, essentially, whereas other languages will automatically clean memory up for you. So the main advantage of smart pointers is that they'll clean up the memory automatically. So if you declare a smart pointer and the object goes out of scope, the smart pointer will automatically have its memory cleaned up as it goes out of scope, solving that issue, essentially. So in modern C++, there's 3 types of smart pointers. I hope there's only 3, otherwise I look a bit stupid. So shared pointers basically keep a reference counter of all of the pointers pointing to an object. So at any one time, if you have an object and there's multiple pointers which are all pointing to the same object, and you might have some which are assigned to it and some which are removed, they always keep a reference counter of how many different pointers are pointing to that one object. And then obviously when the reference counter is 0, that's when the memory for the object is automatically cleaned up. A weak pointer does not contain a reference counter. That basically just still smart pointer, so the memory is still cleaned up automatically, but it has no idea of how many different pointers are pointing to an object. It's just if there's anything pointing to it, then it still exists, and when there's none, that's it. And then unique pointer is when one single pointer points to one object only. So you can't have multiple pointers pointing to one object whatsoever. It's just one pointer which points to one object. And you can move the pointer, so you can have a different pointer pointing to the object, but it can only be one at a time, essentially. And then again, if nothing is pointing to the object, the memory is automatically cleaned up. So I hope that kind of explained it, at least in a reasonable way. Some random tips when it comes to programming and stuff. A lot of these you may have heard. Again, I don't know how much of this stuff you will have heard before, so if a lot of it's already very familiar to you, then I'm sorry, but it's what it is. Square rooting something is always a very interesting one. Square rooting is very expensive as an operation compared to like addition or subtraction or multiplication or something like that. Square rooting is a very expensive operation on the CPU. It takes a lot of processes to be able to handle it because it's a very complex operation. So there's often a lot of smart ways you can avoid square rooting something. So I think the obvious example which can be used is just like distance checks. So if you're checking for distance between 2 objects, you'll obviously kind of square the position vectors for the 2 and add them together or whatever it is to find the distance between them. And then usually you would square root that value to get the distance. But instead, if you want to check if the distance is like less than 100, say, rather than doing the square root operation to find the final distance between them, you can leave it as squared and just square the distance itself. So you can do, is it less than 100 squared, rather than is the square root less than 100, if that makes sense. I probably should have typed this out because it would have been clearer, but yeah, because squaring something is basically so much simpler than square rooting it that it's actually worth doing that to just save those processes, especially if it's something which you're doing multiple times in like a few frames or something like that. Another tip is to kind of think about FPS and frame time as different things. As you always kind of like hear a lot of talk about FPS, like, oh, game 60 FPS or 30 FPS or whatever. But you really, as developers, you really kind of want to focus on like the frame time of something. Is like, how long have we got for a frame? So we want the game to run at 60 FPS. That means it needs to be 16.6 milliseconds for a frame. What's our budget on that frame? How long do we have for rendering? How long do we have for physics? All that kind of stuff. And then it can also, because FPS is just an average as well, so that's not really a very helpful metric to be able to say how well the game's running, because FPS could mean multiple different things. It could be like, if the FPS is measured over a minute, it could be that one frame is taking like 16 milliseconds and the next one's taking 33, and that's alternating. And that's going to look very different to a consistent 45 FPS, where it's however many milliseconds that would be, but like a consistent amount for every frame. So that's like frame pacing, essentially. So how much memory all the kind of data types used in whatever language it is you're writing is something which is quite interesting to be aware of as well. So for example, a Boolean, obviously that's just a true or false value, so 0 or 1. So that would just use kind of like 1 bit of memory you would expect. But no, a Boolean actually uses a byte of memory, so 8 bits. So that basically just results in 7 zeros and then either a 1 or a 0, depending on if it's true or false. There is reasons for that. That's in C++ as well, and 64-bit, blah, blah, blah. So there is reasons for that in that like the smallest amount of memory which can be actually read is often 1 byte. So that's why a Boolean has to be stored in 1 byte just for that ease. But there is also ways of, for kind of, I guess, for more memory stringent type use cases, there is ways to kind of pack a Boolean down to only be a single bit. So you can do kind of like bit shift operations, which sound very scary and maybe a little bit cool in a way. But it's quite simple, really. That's kind of a common thing to do with like Unreal, just to kind of like only store a Boolean in a single bit rather than a whole byte. And also there's some other optimizations which kind of the language will do automatically. So if you have an array of Booleans, say you have an array of 8 Booleans, it's not going to store that in 8 bytes. It's just going to store 1 bit for each Boolean in the array. So there's already some optimization which is done there for you anyway. When debugging as well, recognizing things like the max int value, so 2.454 billion or whatever it is, positive to negative. Just being able to kind of like know what those numbers are, not necessarily the whole number off by heart, but just being able to look at something and go, that looks like the max int value, like what's going on there? Like it's often, because obviously that then shows that in memory, that int is just all ones for some reason. So there's probably something really wrong going on there. Like, and it can just be easier to track down issues. It's not just kind of like, because otherwise, if you don't know what that number is, you're just going to look and say, oh, why is this random massive number here that means nothing to me? It's just easier to kind of speed things up in that sense. Floating point precision is another thing to be aware of. Obviously, it's not, you can't store all of pi in a single float, because that would be ridiculous. There's only 8 bytes of memory for a float, which leads to basically like a different number of bits. I think it's like 7 bits for the exponent and 16. No, I've got that wrong. I can't remember. That's what Google's for. But basically, there's only like 7 or 8 decimal places of precision for a floating point number. And then that obviously like increases quite a lot if you're using a double. So you kind of just need to be aware. For games, kind of like you can get away with using floats quite a lot because we're not really needing that precise level of calculations. But if you're doing kind of like astronomy calculations or highly like science specific kind of like really accurate measurements for things, you'll need like a higher like precision value for those things, because kind of like is a lot more important to get highly accurate numbers rather than just in programming. So specifically talking about programming on Unreal Engine, as I feel like that's kind of like the most common place for students to kind of learn making games in a way. It's where I would advise doing it. Unity is really good for kind of lower level, first starting out. But I really think Unreal Engine is kind of like a good place to push because it kind of like is used by a lot of big development studios and teaches you a lot about professional standards of making games. So in Unreal, there's obviously kind of like a lot of base types which already exist. There'll be kind of like a character type which might exist, and an actor, and a pawn, and there'll be a lot of these base types, and a lot of times you can kind of just go like, oh yeah, I'll just like derive from that base type and create my character class from like deriving from their character class essentially. And it's like, do you actually need to do that? Like, make sure you kind of look into what is actually in these classes. Like, are you even going to be using any of the functionality that's in there? There could just be a whole load of functions which you never need to use, and at some point it kind of becomes, maybe I should just create my own class which doesn't actually derive from this, it derives from something else at a bit lower level, and I can simplify things and not waste time updating a bunch of values which I don't actually want to use. Blueprints are really good for kind of prototyping and when you're first learning out, and for getting things kind of like going essentially, but you'll always be told to avoid using blueprints in production code. They're just too slow, really. There will always be, again, with a lot of this stuff, there'll always be those use cases where you will use blueprints for some reason, but generally speaking, it's kind of like, don't put blueprints in production code is a good rule. This is a good quote. This is, again, from one of the tech leads at Lucid. I remember reading some documentation and coming across this one, and it's stuck with me ever since then. Each time tick is called, a small child feels pain. So tick is essentially the update function in Unreal, and all actors will have the tick function, which can be called, but it should not be called when possible. So essentially, you just really need to be aware of if this thing needs to be called in tick, because if it is, that's being called every single frame. So 60 times every second, that function is being called. So you really need to be aware of kind of like when you're doing something in there, that's happening that often, that's going to cost like a lot every single frame potentially. So can you do it somewhere else? Do you need to do it in tick? Can you do it like when the object is initialized, or maybe if it's event driven, when only a certain thing happens, just call the thing once rather than kind of calling it every single frame. Get used to profiling code as well. That's something which definitely I personally, this is almost a reminder for myself as well, essentially, and that optimization and stuff will come a lot from profiling the code itself. So there's a lot of kind of like built-in tools for Unreal you can use, which will help you with profiling code, and that will basically kind of break down the frame as the game is running and say, here's what's happening, here's the functions which are being called on which objects, and here's how long it's taking. And it's just really easy to see glaring issues where it's like, oh, updating all of our like AI actors every single frame, and it's taken ages. Like, what optimizations can we do there? Stuff like that. Like, that's the only way you can see how well something is running, is by profiling the code and seeing how long is it taking. You can't really guess, because that would just take way too long. So just to kind of like shout out the Lucid Games stuff, we literally yesterday, actually, which is quite good, put up our student careers page. So it's sort of designed for students looking for internships, which is what I did. So I'm definitely a big advocate for this, because doing the internship essentially helped me get my job in the end as well. So yeah, I can't like speak to this enough, really. So we've just opened up applications for that. So if you're like a second-year student at university and you're wanting to kind of like take a gap year, if that's something which is offered on the course, to kind of go and do an internship, then literally yesterday stuff has opened up. So now's a good chance to kind of like, you can see it linked at the top there. if you want to go have a look, or just Google it, whatever. Also, like, follow on Twitter and stuff like that, and there'll always be updates posted on there. Yeah, that's about all I've got in terms of that stuff. So we can do some questions, and then if there's any time at the end, I don't even know what time is, but I can kind of do some live coding stuff. That will be a bit off the cuff, as we've had some technical issues, but if we've got time, then I'll go over a bit of stuff. But yeah, if there's any questions or anything, then I'll be happy to answer. Or you can find me on LinkedIn, Twitter, email me, whatever you need, and I'll do the best to answer.
Yeah, I'm just wondering, because obviously you use Frostbite engine a bit, and I know you can't talk too much about it, but what's it like using like an in-house engine which you've like never touched before? Because a lot of jobs seem to like ask, oh, have you used an in-house engine because that's useful, but like obviously not everyone has.
Yeah, so that's definitely like one of those interesting challenges which you can never really be too prepared for, because you can look at the open source engines, Unreal and Unity and stuff like that, and you can be as prepared as you like for those, but you're always going to end up probably working somewhere where they have their own in-house engine. And there is a lot of like similarities and stuff across engines. Like a lot of these like don't necessarily reinvent the wheel. There's always different ways of doing things, different processes and stuff like that, but you'll always find like, oh yeah, that's quite similar to Unreal, or oh, that's kind of like slightly different than Unreal. And trying to be very careful about what I say here. There's obviously like going to be documentation on the in-house engine, and I know one piece of documentation I found really useful was like Frostbite for Unreal coders. So it was basically like, oh, so you've got a lot of experience with Unreal and now you're using Frostbite for the first time. Here's everything you, like, oh, you want to do this thing because you've done it in Unreal, here's how you do it in Frostbite, essentially. So there's often like really good documentation for in-house engines and stuff like that, which kind of mean that they may expect you to have experience with Unreal, so they'll kind of have some documentation there, which is kind of like, here's how you're used to doing things, here's how it's done in Frostbite instead, stuff like that. So you can, again, it just kind of comes down to being really good at learning quickly kind of thing. But at the same time, you're not going to be thrown into kind of like, oh, here's Frostbite, I want that feature done next week. It's going to be like, they're going to give you time to kind of do some like little onboarding tasks, do some basic stuff, and then kind of actually move on to making real things after that. So yeah, it'll be fine.
Do we have any more questions from anyone else? Okay, well, thank you very much for coming today, James. It was a super informative presentation, and it's a bit of a shame we didn't get to see the programming aspect at the end of it, but we did have a few technical issues, and we apologize for that. Big round of applause for James, everybody. And thank you very much.
Thank you, cheers.